Okay, in this video, I would like to let you know how to implement the different design using R. Okay, so you can see the R script, DIDR, and we will use this EITC DTA data, and you need to install this package. And the example we use is the same as we mentioned in the data class. It's about the effect of the tax credit on labor supply. And this is about the earned income tax credit in US. This EITC is a refundable tax credit that subsidize earnings of the working poor in US. And the amount of cash transfer depends on the number of children and their previous earnings. And in 1994, the amount of EITCs had very large increase for those who have children, but have almost no change for those who do not have children. So the author want to examine how does this change affect people's labor supply. So using the DID approach. So the EITC benefit rule, as I mentioned in the class, depends on the family income and the number of children. And so this is the EITC cash transfer you will receive. And it depends on family income. If your family income is very low in the very beginning, very low, $1 you earn, the government will give you more transfer. So it's kind of like the negative tax. It's not if you earn more, the government will tax you, impose more tax on you more. No, because they want to encourage these poor people to earn more. So when your income increase, the government will not just impose tax, is just give you the more subsidy. So that will give you more cash transfer until your family income reach some certain amount. And then the amount of cash transfer will decrease until, for example, 40,000 US dollars. The EIT's amount becomes zero, like this. And this amount before 1994 is quite small, like this. But after 1994, for those who have children, their amount of cash transfer they receive will become much larger. So for example, for those who have one children, at most they can receive 3,000 US dollar. And for those who have 2 children, they can receive 4,500 US dollars. Okay, so that may very big increase compared to the no children, the people who do not have children. Okay, so given this background, we can define the treatment group and control group. So the treatment group is those who have at least 1 children. So they will receive much more tax credit after 1994. And for the control group is those who do not have children. So their tax credit will not increase after 1994. Almost the same. So they want to know how does this expansion in the tax credit on treatment groups labor supply. So here we can define the treatment group and control group. So treatment group equal to 1 means this guy has at least 1 children. And 0 means they do not have children. And post is equal to 1 means this individual was observed after 1984. 0 means this individual was observed before 1984. And we want to focus on the treatment group dummy times post dummy. That is represent the individual was affected by the 1984 EITC expansion because they are in the treatment group, they have children, and they also observed after 1984, and that is the period they will receive much larger EITC amount. And this coefficient will capture the difference in the trend between the treatment group and control group after 1984. And this difference in trend should be captured the causal effect of the EITC expansion in 1994. So the first is you need to create several new variables in your data set. So let me open the R. So first things is, again, you clean all the data, clean, and then you load some package and also read your data set. So you will create a new data object called EITC data. So this data file is individual level data. And then you create several dummy variables for treatment group, post-treatment periods, and their interaction term. So this is the way you can create the new variable in the R. This is your object, and you want to create this new variable, you can use this $sign. And now this variable will equal to 1 if this condition satisfied. So this, you remember, this is the index. That means if the variable in this data frame is satisfied bigger than 1, you will assign 1 to this new variable. And very similarly, if the children equal to 0, you will assign 0 to any kids, this new variable. And again, very similar, you create a new variable called post-93, is the year after 1984, you assign 1. If this is smaller than 1984, you assign 0. And the key variable for the DID analysis is the post-93 times any kids. So in R, you use $sign to kind of like get the variable in this object. So you can then create 3 new variable, any kids, post 93 EITC. Okay. And then before doing regression analysis, you can do some graphical analysis. So the first important key assumption of DID is you want to verify whether the treatment group and control group have common trend before the reform. And you also want to show the outcome of the treatment group really exists with different trend after the reform. So you can use the ggplot to create your graph object using this data object, and you need to specify what's your x-axis, what's your y-axis, the work, and the color you want to show difference by the treatment status. And here is the important function called state summary. It can help you to get the summary statistics based on the group, based on the year, based on your x variable, and using the y variable to draw the graph. And you can specify you want to draw the line. The gmod function is line. So that will generate the summary statistics. Basically is average work employment rate by year and directly. And you also say I want to separate to 2 colors. One is for treatment group, another is for control group. And another you also add one more gmod function is the vertical line. So you want to show the 1984 is a specific line. It's a treatment reform happened. And finally, you put something and save your result, your table. So that is basically what we do here. So you can implement, and the result will show here, and you can save. Okay. And you can find actually for the treatment group, their labor supply suddenly increased after 1984, and for control group, they does not have this change. And you can see before the reform, they have very similar trend. And finally, you can directly estimate your DID regression by running this OLS. The outcome is your the labor supply employment. And the key variable is treatment group dummy, post-treatment dummy, and their interaction, the EITC. And the data is here. So you can, and then finally you get assigned your result to this object and show the result. Okay. So that is this, and that will show the results here. Suggest the EITC expansion will increase the treatment group's employment rate by 4 percentage points. So it's very large and significant. And finally, you can do some placebo test. And you use the period before 1984 to do this placebo test. And you say 1992 there's some reform, but actually not. And you want to see whether during that period actually there's no treatment effect happen. And you do exactly the same thing, create the same similar variable and run similar OS regression, and you expect again nothing, no effect. Okay, so you can play with this code. Okay, so that's all for the DID design. Thanks.